Organized counting. This is a precursor or a prerequisite set of skills to bring us to understanding of permutations and combinations. The first example is going to use a tree diagram to express our solution. An example about travel itineraries. Martin lives in Kingston and is planning a trip to Vienna, Austria. He checks a website offering inexpensive airfares and finds that if he travels through London, England, the fare is much lower. There are 3 flights available from Toronto to London, 2 flights from London to Vienna. If Martin can take a bus, plane, or train from Kingston to Toronto, how many ways can he travel from Kingston to Vienna? So there's 3 legs of this trip. The first leg, you arrive in Toronto. The second, you arrive in London. And the third, you arrive in Vienna. To get to Toronto, there are 3 different ways you can arrive: by bus, plane, or train. Once you're into Toronto, there are 3 flights from Toronto to London. So there's 3 different ways, no matter how you come, that you can get all the way to London. So I'm going to number these 1, 2, and 3. And you can see that this is the beginning of our tree diagram now. So I'll do that for each of the choices: the bus, plane, and the train. And once you're in London now, you have 2 flights from London to Vienna. So each one of these has 2 more arms of the tree. Branches, I suppose, is the correct word. So there's our branch. And I'm going to number them 1 and 2. And I'm getting really small. 1, 2, 1, 2, 1, and 2. So now if you look at the last column here, if you count the number of ways you can get from Kingston to Vienna, you'll notice that there are 18 different paths from Kingston all the way to Vienna. There is an easier way to do this. Rather than drawing out a tree diagram, you'll notice that there are 3 different ways to get to Toronto. There are 3 different ways to get to London, and from there are 2 different ways to get to Vienna. 3 times 3 times 2 equals 18. So you can multiply through each of your choices at each destination to give you the number of possibilities that you can arrive at the end. So we're going to take our first example now and formally let you know that that was called the fundamental or multiplicative counting principle. So you can use a tree diagram to express it, but you can also multiply through and given the data in the problem to find the number of ways. In this example, we have stereo systems. Javon is looking at stereos in an electronics store. The store has 5 types of receivers, 4 types of CD players, and 5 types of speakers. How many different choices of stereo systems does this store offer? So receivers, you have 5. CD players, you have 4. Speakers, you have 5. You multiply through. 5 times 4 times 5 is 100 different stereo systems that are possible to buy from this store. As we go through these examples, please pause before I show the answer and see if you can get there before I show you. So another example, same sort of thing, fundamental or multiplicative counting principle, and this case is a school band picking out uniforms. So a school band often performs at benefits and other functions outside the school. so its members are looking into buying band uniforms. The band committee is considering 4 different white shirts, dress pants in gray, navy, or black, and black or gray vests with the school crest. How many different designs for the band uniform is the committee considering? So we have pants, we have shirts, and we have vests. 4 different pants, gray, navy, or black. So that means we have 3 different shirts, black or gray vests, which means we have 2 different vests. Multiply through 4 times 3 times 2. We have 24 different band uniforms that the committee is considering. Now we're going to look at something a little bit different. This is called the indirect method. The indirect method means you subtract from the total the case that you do not want to get to what you're actually trying to find. So Leoria, a triathlete, has 4 pairs of running shoes loose in a gym bag. In how many ways can she pull out 2 unmatched shoes, one after the other? All right, 4 pairs of running shoes, that means 8 shoes total. So we want to know the total ways that you can pull out one shoe after the other. And since we're trying to find the unmatched, we're going to subtract the number of ways you can pull out a matched set. And if you take the matched set away from the total, that will equal the number of ways you can pull out a set of unmatched shoes. So how many ways can you pull out one shoe after the other from the gym bag? Well, you've got 8 shoes to begin with, so you have 8 choices to start. But once you pull a shoe out, you only have 7 choices the second time. So the total number of ways you can pull 2 shoes out of the gym bag is 56. Now let's look at the number of ways you can pull out a pair of matched shoes. Well, we have 4 pairs of running shoes, and each of those has a left shoe and a right shoe. So you have 4 pairs, and you can either pull the left one out first or the right one out first. So 4 times 2, so there are 8 different ways you can pull out a pair of matched shoes. And this now gives us the total number of ways to pull out a set of unmatched shoes. You subtract the matched from the total, and that gives you 48 ways to pull out a set of unmatched shoes. This is called the indirect method. The last word problem in this video is going to deal with mutually exclusive cases. It's known as the additive counting principle or rule of sum. So in this situation, signal flags, ships used to send messages with signal flags flown from their masts. How many different signals are possible with a set of 4 distinct flags if a minimum of 2 flags is used for each signal? Minimum of 2 flags, which means we'll have a case where there are 2 flags, we'll have a case where there are 3 flags, and a case where there are 4 flags. So let's deal with them individually. I'll draw 4 flags up here. All right, in the case of using 2 flags, the first flag that you fly, you will have 4 choices. Once you've used up 1 flag, you only have 3 choices left for your second flag. So again, that multiplicative principle, there are 12 ways in which to fly 2 flags from a set of 4. In the second case now, we want to use 3 flags. So again, the choice for for the first flag that you fly, you're choosing from 4. Once you've used up 1 flag, you're choosing from a set of 3. And once you've chosen your second flag, you've only got 2 left, so you're choosing from 2. And that will give you a total of 24. In the last case, we're going to use all 4 flags this time. So to fly the first flag, you have 4 different choices. Once you've used it up, you have 3 different choices, and then 2. And then finally, you're left with 1 flag, so you only have the 1 choice. But that comes with the same number of 24. Now when you're dealing with cases, it is additive. So you're adding these all up, and now you have 60 different ways in which to make a signal with at least 2 flags. Thanks for listening.